We're revisiting rationalizing the denominator for the last half of the section, or the last part of the section. Remember, it's rude to leave a root in the denominator. It's not really rude, but I say it's rude to help you remember that it's not correct. To get rid of the root in the denominator, we need to use a fancy one. We talked about this before. We used it earlier in this section, the section before. So just a quick review again. If I want to make this not rude, I need to multiply by what? Square root of 2 over the square root of 2, and I get root 2 over 2. Good. And this one? My fancy one is the square root of 3 over the square root of 3, and I get? Good. And then does that reduce? No. That's the answer. And the last one, what do we do? The square root of 5 over the square root of 5. Not possible isn't a valid answer. Yes, 5 root 10, the stuff inside multiplies, divided by 5. Does that reduce? Yeah, to what? Yeah, it's just the square root of 10. So that's our answer there. All right, now the idea is we have to get rid of the root in the denominator. In order to do that, we multiply by a fancy 1. The fancy 1 is designed to get rid of the root in the denominator. So if this was actually the cube root of 5, then I'd have to multiply by the cube root of 5 squared to make the exponent match the index so that they would wipe each other out, and then I'd be left with the 5. All right? So it's always been not just like the square root or whatever, but it's an appropriate fancy 1 that actually gets the job done for us. Now, on these two problems, we have to try to think about what an appropriate fancy 1 is going to be. It's still going to be a fancy 1. We cannot subtract those. Those are not like roots. They have the same index, but not the same number inside. So we're going to have to multiply by a fancy 1. Nope, I got it right here. It's the conjugate. Yesterday, here, I can bounce back real quick. We saw conjugates right here. When we multiplied conjugates together, the roots disappeared. And that is how we're going to have to get rid of roots that look like that in the denominator. So I can multiply by the square root of 5 plus the square root of 2. That's my fancy 1, plus the square root of 2. It's not the greatest. The numerator is going to be kind of complicated, but it gets rid of the rude part in the denominator, and that's what we're after. Yeah, conjugates are change the sign in the middle. All right, so now in the denominator, because they're conjugates, I know the O and the I in FOIL is going to disappear. So the square root of 5 times the square root of 5 is what? 5. And then the negative square root of 2 times the positive square root of 2 is going to be minus 2. The O and the I parts disappeared. If you were to multiply the O and the I, then you'd have the square root of 5 times the square root of 2, which is positive square root 10. Negative square root of 2, positive square root of 5, multiply those together, you get negative square root 10. You add them together and they become 0. They disappear. Like always with conjugates. So we get 5 minus 2 here, which is just 3. Very nice. The numerator is a little bit more tricky. We're going to have to distribute. The 3 square root 2 distributes in this case. So like last time, what's outside multiplies together, what's inside multiplies together, but what's outside does not multiply with what's inside. So when I distribute 3 square root 2 times square root 5, what do I get? Good, 3 root 10. Plus 3, technically 3 root 4. Yeah, so that is, the square root of 4 is 2. 2 times 3 is 6. 3 root 10, I can't simplify, so I'm going to write 6 plus 3 root 10. Does that reduce? Yeah, because there's a factor of 3 in each one of these outside things, I can divide everything by 3. This is like 6 plus 3x. Can I add 6 plus 3x? No, same thing is true here. So I divide all those outside things by 3 and I get technically divided by 1, which I don't have to write. So that's my answer. Why don't you write the 1? Because if I had to write 1 in front of everything that had a 1 in front of it, I'd never stop writing 1s. Anything divided by 1 is itself. So if I divide this by 1, it's the same as saying 2 plus the square root of 10, because that's what you have, right? Jimbo divided by 1 is still just Jimbo. So there's, you don't walk around saying Mom divided by 1. You just say Mom. All right, let's talk about the second one. What should we do to simplify that? Multiply by the fancy one, and the fancy one here is going to be the conjugate. Square root 3 plus square root 5. Square root 3 plus square root 5. Okay. Now what? Yes. This will be 3 and then minus 5 on the bottom. So here, I'll show you. We're going to actually FOIL this out. This is FOIL that's going on here. Okay? So we have the square root of 3 times the square root of 3. If I'm FOILing it, that gives me the square root of 9, which is just 3. Then I have the square root of 3 times the square root of 5, which is plus the square root of 15. Then I have the negative square root of 5 times the positive square root of 3, which is minus the square root of 15. And then I have minus square root 5 times positive square root 5, which is minus square root 25. Square root 25 is 5. So minus 5. Well, this stuff right here is the same. Positive 15, square root 15 minus square root 15 disappears. And so I'm left with 3 minus 5. That's where that minus sign came from. Okay? All right, so we have our denominator. Our numerator, how do we do that? Distribute. This is distribution here. So what do we get? Good. 2 root 21. Okay, now we got to simplify that if we can. Does 2 root 21, does that simplify? If it did, there'd be a perfect square in 21, and there isn't. 7 times 3 doesn't work. How about 35? Is there a perfect square in 35? 5 times 7? Those are your factors. Neither of those are perfect squares. So no, that doesn't simplify, but the bottom does. So we have 2 square root 21 plus 2 square root 35 divided by negative 2. Okay, does that reduce? Yes. Negative root 21 minus root 35. Good. Why was it negative root 21? Yeah, because we divided by negative 2. Basically what we're doing is we're saying 2 root 21 divided by negative 2. That's negative root 21. And here we're saying 2 root 35 divided by negative 2, which is negative root 35. So that's where that minus sign comes from. That's how you do problems that look like this. Either they're going to look like this, and it's just a fancy one like we normally work with, or it's going to look like this, and that just means multiply by the conjugate for your fancy one. So that's it for this section.